Hello everyone, my name is Dmitrii Annenkov, Kelly Conlon, Sam Lee, and David Schmidt, and we're presenting the ergonomic assessment and work analysis of foam manufacturing facility. The manufacturing facility supplies foam for automotive companies such as Ford, Tesla, and FCA. The facility produces various shapes of foam ranging from bucket seat to the bench seat. To give a brief overview of the overall operation, firstly, the workers place the green straps, orange clips, cloths, or wire into the mold depending on the seat type. For our project, we will focus on the foam assembly line where there are a lot of human motions.
The foam assembly line moves at a pace of 50 feet per second. As shown in the figure below, the assembly process often requires workers to bend over to reach the end of the mold. Each operator varies in size and height, from 4'10" to 6'2". Therefore, they have varying reach limits. It is important to analyze their fatigue levels on their shoulders, back, and fingers to ensure safety. The three main goals of our project are to determine the source of waste present in the standard method, recommend ways to reduce fatigue levels, particularly on shoulder, back, and fingers, and allocate the work among operators in a way that increases productivity and worker safety. Workers spend considerable amount of time turning around and collecting parts from the racks and shelves. In almost all circumstances, workers need to bend over to place parts on the mold. Regardless of height, all workers are required to perform roughly all the same tasks. We took measurements of the dimension of the production line, created a sketch file of the facility, conducted time studies, and completed ergonomic assessment.
From the team's measurements, a SketchUp model was created where the reach envelopes of 95th percentile males and 5th percentile females were placed into the model to assess the ergonomics of the shelves, racks, and assembly line. The figure on the left shows that the workers can only reach approximately a quarter of the production line without bending. The figure on the right helped us analyze that the bottom two shelves cannot be reached by the workers without bending. At least 1/3 of the supplies were retrieved by workers from the second shelf above the floor, meaning that workers had to bend to retrieve parts at least once every 3 trips. When a worker completes a task, he or she is either doing value-added or non-value-added work. Non-value-added activities include waiting for the production line to advance and pulling parts from the racks and shelves. The remaining time is spent placing parts on the mold. A time study was conducted to separate value-added and non-value-added activities. The molds were partitioned into a top and bottom section. Additionally, whether the final location of a part was near to or far from the worker was recorded in the time study. It was observed that workers spend approximately 50% of their time doing non-value-added work.
All of the operators insert orange clips to the molds. These orange clips require an extra force to open and place onto the mold. The fatigue level was calculated using a lateral pinch approximation for a binder clip. The maximum strength for a male and female was 25 pounds and 18 pounds respectively. The percent MVC was then calculated from this maximum strength input and the binder clip strength approximation. Finally, the MODAPS for placing 3 clips onto the mold was calculated to be 3.1 seconds. The percent MVC calculated for the clip placement was plotted on the duty cycle versus percent MVC curve, resulting in a maximum duty cycle of 35% for males and 18% for females. The observed duty cycles for the workers' finger use was higher than these maximum cycles in 4 out of the 10 observed workers. All of these 4 workers were female. Thus, work must be reallocated to prevent finger fatigue in female workers. Next, shoulder fatigue was analyzed by collecting the angles between a worker's back and upper arm for each part placement. The percent MVC of the shoulder was calculated through the 3DSS PP program for each worker's most frequent location of part placement. The percent MVCs calculated were quite small for each worker, much smaller than the maximum duty cycles recommended. Therefore, shoulder use is not of particular concern at this time. Similarly, to assess back fatigue, the angles between workers' pelvises and upper backs were recorded for each part placement. The compression of the lower back was calculated in 3DSS-PP for the worker's most strenuous task on the back. This task was placing parts in the bottom far portion of the mold, as seen in the figure on the right. 5 workers' back compressions exceeded 770 pounds, which is the NIOSH recommended back compression value. Thus, work must be reallocated to prevent L5-S1 disc injury.
We recommend to implement 5 potential solutions to reduce the back and finger fatigue levels. First, a cantilever shelf would allow each worker to position the shelves to a comfortable height. The customized shelf height will allow both female and male workers to bend less. Second, we recommend that the operators wear a parts apron to hold orange clips, as workers will be making far fewer trips to the supply racks and shelves.
The finger fatigue analysis shows that 4 operators exceeded the maximum duty cycle for finger use. To resolve this issue, we recommend that management allocate clipping tasks such that each operator completes roughly the same amount of clipping. The back fatigue analysis shows that 5 operators exceeded the NIOSH recommended back compression threshold. To resolve this issue, we recommend that management reallocate tasks such that each operator completes roughly the same amount of reaches to the bottom far portion of the line. Last, by tilting the far end of the conveyor towards the operators will be able to bend less to reach the back of the mold. By doing so, risk of back fatigue will be reduced.
We would like to thank our professor, Thomas Armstrong, for his help with the project. Thank you for your time, and if you have any questions, feel free to ask them after the video.